State and explain the law used to determine magnetic field at a point due to a current element. Derive the expression for the magnetic field due to a current, circular current carrying a loop of radius r at its center. Okay. Now first we will see the definition, that is a Biot-Savart law we are going to use here. That it determines the magnetic field at any point due to current carrying conductor. According to Biot-Savart law, the magnetic field at a point P, which is at a distance r from the current element, is given by, that is that we denoted by the symbol that is dB. dB vector is equal to K times IDL into R divided by R cubed. We can write this one as, again, dB vector is equal to K times IDL sine theta, then R will get cancelled, then it becomes R square. Then B vector is equal to integration over dB vector, that is equal to mu naught divided by 4 pi, it's a constant, and integration with respect with I dl sine theta divided by r square. This is the expression. Now consider a circular loop of radius r and a small current element dl. Then the magnetic field due to the current element at the center O of the circle is given by, then dB vector is equal to K times IDL into R divided by R cube. Then dB vector is equal to K times IDL sine theta divided by R square. Now, for a total magnetic field, this becomes B vector is equal to integration over dB vector is equal to mu naught divided by 4 pi integration over I times dl sine 90 divided by r square, which is equal to mu naught I divided by 4 pi r square equation to with respect to di, which is equal to mu naught I divided by 4 pi r square into 2 pi r. We'll get the value mu naught I divided by 2r. Okay, then this is the first case. Then for the B, a long wire with a small current element of length 1 centimeter is placed at the origin and carries a current of 10 amperes along the x-axis. Find out the magnitude and direction of the magnetic field due to the element on y-axis at a distance 0.5 from it. Okay, then the given data, length of the wire is equal to 1 centimeter, current carry is equal to 10 amperes. Now the direction of the magnetic fields, that is, here the direction of the magnetic field is given by dB vector is equal to mu naught I divided by 4 pi times dl sine theta divided by r square, then which is equal to 4 pi divided by 4 pi, it's times 10 to the power of minus 7 into 10 into 1 into 10 to the power of minus 2 divided by 0.5 square sine 90 degree. Sine 90 degree. Then we will get the answer 4 into 10 to the power of minus 8 t in z direction. In z direction. Derive the expression for the magnetic field due to a current carrying coil of radius r at a distance x from the center along the x-axis. Okay. So the magnetic field derivation we can do with the help of the according to Biot-Savart law. Then according to the Biot-Savart law, we know that dB mod of dB vector is equal to mu naught divided by 4 pi times I into dl sine 90 degree divided by mod of r1 vector whole square. Okay, this is the equation we are going to use here. Then, if the current carrying coil of the radius r at the distance of x from the center along the x-axis, then here where r is equal to the under root of x square plus r square. That means according to Pythagoras theorem, if you are going to take, then r square is equal to a base and a adjacent square, that is equal to r square plus x square. Then r is equal to this square and this square. Then we can write this one as mod of, that is where r is equal to under root of x square plus r square. Then dB is equal to mu naught divided by 4 pi into I dl upon x square plus r square to the power of 3 by 2. Okay. Then the direction of a dB is perpendicular to the vector d and vector rr. It is a components of dbx and db perpendicular. The components db perpendicular due to the whole coil cancel out in pairs. Then the net field B is equal to integration over dbx is equal to integration of db cos theta. dB cos theta. Then vector B is equal to mu 1 into I r square divided by 2 times r square plus x square to the power of 3 by 2. Then we can write it as B is equal to mu naught I divided by 4r. Then the second part of the question, a straight wire carrying a current of 5 amperes is bent into a semicircular arc of radius 2 cm as shown in the figure. Find the magnitude and direction of the magnetic field at the center of the arc. Okay. Then it means that with the data we can directly substitute the values here. B case. Then we have the formula and substitute the values 4 pi into 10 to the power of minus 7 into 5 divided by 4 into 2 into 10 to the power of minus 2. Okay, if I'm going to simplify this one, I'm getting the answer 7.85 into 10 to the power of minus 5t. Okay, that means the field is directed inwards perpendicular to the plane of the page.